Hi everyone, in this video we are going to discuss about the concept of root and radicals. First we need to understand the radical notation and what a root means, right? Now suppose we have two numbers a and b which are real numbers, and also let's suppose we have another number n which is a positive integer or natural number greater than or equal to 2. Now if we have a as b to the power n, then we can say that b is equal to a to the power 1 by n, and b is called the nth root of a. And also it can be written with this little radical symbol here with the n denoted there and then the a inside, right? And we have to make a note of a few terms here. So let me first start writing the name of these terms. So here b would be called the nth root of a, and then the yellow symbol is called the radical sign. We can call it radical symbol or radical sign. And the little n right here, this is called the index, and the a is called the radicand. So when a is equal to b to the power n, then b would be called the nth root of a, and it can be written in two different styles. One would be b is equal to a to the power 1 by n, or we can also say that b is equal to n with the radical symbol and then a inside the radical symbol, right? Like the rightmost side notation, that is the radical notation, and then the middle notation is the exponent notation. So I have tried to show you the nth root of b can be written in two different styles. One would be the exponent notation which is in the middle, and the radical notation which is on the rightmost side. Now if it is looking kind of crazy or overwhelming, let's take a quick little example and then you will exactly know what I am talking about. Say we have 16 is equal to 2 to the power 4. Can we write it like this? Of course we can. 16 is equal to 2 to the power 4, that we know, right? So from here can we say that okay, then 2 must be equal to 16 to the power 1/4, and also it can be written as 4th root of 16. Yes, they both are correct. This is also correct. 2 is equal to 16 to the power 1/4, and also it can be written as 2 is equal to 4th root of 16 using the radical symbol. Similarly, if we have, let's say, a cubed is equal to 27, then we can say okay, then a must be 27 to the power 1/3, or we can also write it as cube root of 27. Now when the index of the radical symbol, when the index is 2, we call it a square root. So let me make a note here. So when the index is 2, we call it a square root, and by the way, the index is omitted. We don't write the index inside the radical symbol. You see, I have not written the 2 in the radical symbol. So this radical symbol without any index means it is the index 2. That means it's a square root. Now how about a cube root? Well, for cube root, it's going to be like this. The index will be 3, and then we have to write it like this. We have to write that little index there. So the cube root notation is going to be like this. Then you will have the radicand inside the radical symbol, and this will be called the cube root. So the first one was square root when n equals 2, and when n equals 3, this is called the cube root. And if n is any higher than that, then it will be called like this. So suppose n is 4, then we have to write it as 4th root of, so it will be read as 4th root of whatever is the radicand, but this will be the 4th root. And similarly, if n is 5, it will be read as 5th root. If n is 6, it will be read as 6th root, and so on, right? Now we are going to talk about the principal nth root. So let's understand what that is. First, we want to take an example. Say suppose we have square root of 16. What would be the value of this? Well, on the side, if we say 4 times 4 or 4 square, that gives us 16. And also if we say negative 4 times negative 4, that also gives us 16. So now if we take a square root of 16, should we say the value should be positive 4 or negative 4, right? That's a very valid question. And when a number is written like this, you can safely assume that there is a positive sign outside. And when the number is written like this, we call it a principal root. Now in this case it is a square root. It could have been a cube root, it could have been a 4th root, but in this particular example it is a square root. But in any case, it will be called the principal square root when we use the positive value like this. If we say this is equal to 4, then actually this is the principal square root or principal nth root, when n would be whatever index that may be, right? In our example the index is 2, so we are calling it a square root. So the principal root is the value which has the same sign as the radicand. You see the radicand itself, the 16, number 16, the radicand has a positive sign. So that is why the principal root is 4. Now what if the radicand had an unknown variable there? For example, if I had, let's say, square root of 16x squared. So now if we had something like this, what would be the value then? Well, we know that 16 is looking positive. We want to find the principal root, the principal square root of this number right here, the 16x squared, 16 times x squared. So square root of 16x squared is actually the principal square root. And what would be the principal square root then? Well, it has to be, the value has to match with the sign of the radicand. But in this case, what is the sign of the radicand here? 16 is positive and x squared is also positive. So 16 times x squared would be positive. So we are tempted to say that the square root of 16 times x squared would be equal to 4 times x. But we actually don't know whether x is positive or negative. What if x is actually a negative number, right? Then your principal square root value is going to become negative, and that is not a good thing. So what we need to do, we need to put a modulus symbol here, or the absolute value symbol. So ultimately this is going to become, 4 can come out of the modulus because 4 is a positive number anyways. So this will be 4 times modulus of x. So now we are going to take a look at the formal definition here, the principal root. So the principal root says that it is the root whose sign matches with the sign of the radicand. So the formal definition of principal root says that the principal root of a number, meaning whatever is the radicand, that principal root is the root value whose sign is same as the radicand, meaning the sign has to match with whatever is that original number which is inside the radical symbol, right? So let's take a couple more example to clarify any doubts. So suppose if we take square root of 25, let's say, and when you are asked to find the value of this, you should never say that this is plus or minus 5. You should always say that this is equal to positive 5. When it is written in this form, that is actually the principal root. In this case, it is a square root. It could have been a cube root or fourth root, but this is called the principal root. And when we are talking about principal root, your root value has to match with the sign of the radicand. For example, I can say that if we have another example, let's say suppose we have cube root of, let's say, negative 8. Right? So this will be what then? Well, this will be negative 2. And again, that is correct because negative 8 is actually negative 2 times negative 2 times negative 2. So then cube root of negative 8 would be negative 2, and that is correct. So this is the principal root. And here again, you see the sign of the root, which is that negative sign right here. The sign of the root, which is this negative sign right here, actually matches with the sign of the radicand. So negative 2 is the principal cube root of negative 8. Next, we are going to discuss about the properties of radicals. So let's talk about the first property, and the first property goes like this. So the first property says that nth root of a to the power m can be written as nth root of a whole to the power m. Now, how can we prove it? Well, let's try to rewrite this first expression here. So this is nth root of a to the power m. This can be written as a to the power m, whatever is the radicand, whole to the power 1 by n. That is from the concept of root and radical. And then can we write it like this? So this will become a to the power m times 1 by n. This is one of the properties of exponent. And then we can also rewrite it as a to the power 1 by n times m. Same thing pretty much. And then from here, can we say that this is a to the power 1 by n whole to the power m. That is again another property of exponent. And then from there we can say, okay, then this must be the nth root of a whole to the power m, right? And that's exactly what the property says, that nth root of a to the power m can be written as nth root of a whole to the power m. Let's take an example. So suppose we have cube root of 64. Can we write it as cube root of 8 square? 8 square would be 64 obviously. And then from here, can we write it as cube root of 8 whole square? And then from here we can say, okay, cube root of 8 would be positive 2 and whole square of that, and that will become 4. So the value of cube root of 64 is actually positive 4. Next, we are going to talk about the second property of radicals, and the second property is going to be like this. The second property says that nth root of a to the power n would be equal to a, and it is very easy to prove. So now nth root of a to the power n, can we write it like this? We can say, okay, this must be a to the power n whole to the power 1 by n, and then from the property of exponent we know that a to the power m whole to the power n would be a to the power m times n. So here the two powers will be multiplied, or the two exponents will be multiplied. So this will become a to the power n times 1 by n, and then guess what? This n in the numerator and 1 in the denominator, they cancel each other. So now we are going to be left with a to the power 1, which is nothing but a. So that's an easy proof there. If you ever see something like this, for example, you say cube root of 8 you know exactly what that is. That is actually cube root of 2 cubed, and this will definitely be equal to 2. Let's talk about the third property. The third property says that mth root of nth root of a can be written as m times nth root of a, right? So how can we prove it? Well, the proof is very easy. So we have mth root of, then again nth root of a, and if you think about it, this can be written as nth root of a whole to the power 1 by m, and this can be written as, within the parenthesis, again we can write it as a to the power 1 by n, because the nth root of a would be a to the power 1 by n, and then we also have whole to the power 1 by m, and then using properties of exponent we can say, okay, now the exponent is going to be multiplied when they are in this form, so it would be 1 divided by n times 1 divided by m, and from there we get this is equal to a to the power 1 divided by m times n. And now you see the form that this is actually, if you assume that m times n is like any other number, then this is actually the m times nth root of a. So this can be written as m times n root of a, right? So for example, if we have, let's say suppose cube root of and then square root of x, for example, so we can write it as sixth root of x, because we have cube root outside and then a square root inside, so that would be 3 times 2, that would be 6. So this will be sixth root of x, and also you can write it as x to the power 1 by 6. Let's now talk about the fourth property. So the fourth property says that nth root of a times nth root of b can be written as nth root of a times b. Now how can we prove it? Well, the proof is pretty easy. So let's try to write it like this. So suppose we have nth root of a times nth root of b, and can we write it as a to the power 1 by n times b to the power 1 by n. So we can write this as a times b to the power 1 by n, that is using the property of exponent, and then this is clearly equal to nth root of a times b, or nth root of ab. Ab is actually a times b. So for example, if we have, let's say, cube root of x times cube root of a, so we can write it as cube root of ax, or a times x. Let's take another example. Say suppose we have cube root of, let's say, 4 times we have cube root of, let's say, 2, so we can write it as cube root of 8, and that will obviously be cube root of 2 cubed, and then this will be equal to 2. Now let's talk about the fifth property. The fifth property is going to be like this. So the fifth property says that nth root of a divided by nth root of b, that will be equal to nth root of a divided by b. Now how can we prove it? Well, it's pretty easy. So let's try to prove it. So suppose we have nth root of a and divided by nth root of b. Can we write it as a to the power 1 by n divided by b to the power 1 by n, and then using the properties of exponent, can we write it as 1 by n power of a divided by b, that is using the property of exponent, and then from here we can clearly see that, well, this is definitely the nth root of a divided by b, right? Suppose let's take an example. If we have cube root of x divided by cube root of 3, we can say, okay, this must be, then we can say this would be cube root of x divided by 3. If we take another example, let's say suppose we have square root of a divided by square root of b, we can also write it as square root of a divided by b. Next, we are going to discuss about two important properties here. Well, they are actually results of one of these properties. The first one says that nth root of a to the power n, it can have two possible values depending on the value of n. So if n is even, then the value should be absolute value of a, because this is the principal nth root. So for principal nth root, when we have an unknown variable, we really cannot take any chance, because ultimately we have to get a positive value. So then this will be absolute value of a when n is even, but when n is odd, then its value will be a. When the power is odd, obviously the sign of a will match with the sign of a to the power n, but when the power is even, we don't know whether a is a positive number or negative number, because for an even power, ultimately it will look like a positive value, but again we never know, right? So we have to use the absolute value sign or the modulus sign. So this is very important property. Please make a note of it. In fact, I have created another video on this topic. I'll provide the link in the description. Feel free to watch that video also. I have explained this type of scenario there. Now to take an example, suppose if somebody says that square root of 36a squared, we will be tempted to write it as 6 times a, but we have to be careful because here we are talking about an even root. Here the index n is actually 2. We are talking about square root, so the n is 2, which is even. Then we cannot say it like this because we really don't know whether a is a positive number or a negative number. So we have to use the absolute value sign. So we have to put this entire thing in the absolute value sign, but 6 will come out easily because 6 is a positive number, and then we have to say this is the square root of 36a squared. But if we had a, for example, if we had a cube root of, so I am taking an odd root here, meaning index odd. So here say cube root of 125, right? And we know that this is going to be cube root of 5 cubed. 125 is 5 cubed, so this value can be written as 5 without any modulus sign, because in this case n is odd. Now if we are talking about 125, then negative 5 cubed can never be positive 125. It has to be positive 5 cubed, right? So essentially what I am saying, we can write it as cube root of positive 5 cubed. There is no other way we can denote this, right? We cannot have a negative 5 cubed because it's a positive 125. So it will be like this. And from here we can easily say that this is equal to 5. But if we had cube root of negative 125, then we have to say it like this. Then this will be equal to cube root of negative 5 cubed, and that will be equal to negative 5. I hope everything made sense. Thank you for watching. See you in the next video.